Thank you very much for having me. I'm excited to give a presentation for this group. I like following along with your newsletters and seeing what's happening up here and interacting with you guys, uh, doing various work up in the Missisquoi watershed. So today I'm going to be giving a high overview of sort of the some of the wild trout and temperature monitoring work that we've done in the upper Missisquoi watershed. Again, there's as we start getting into some of the data, there's a thousand different ways we could talk about it and display it. I'm going to give that high overview and open it up to questions, hopefully at the end, and answer anything and have follow-up conversations in the future if anyone desires. But with that, I'll hop into it. Just a bit of background about myself. I grew up in West Swanton, along the shores of Lake Champlain, so I'm quite familiar with the Missisquoi River watershed, but the lower half of it. Basically anything upstream of Franklin or East Berkshire, it's close to the Trout River. That was foreign country to me upstream. So to know about the Orleans County portion of the watershed was nothing I ever interacted with growing up. I began working for the Vermont Fish and Wildlife Department in 2017. I started down in the Springfield office, actually, but then moved up to the Essex Junction office in 2019, where I am now. And it was at that point where, because of the nature of my job, you can see the distribution of that district that I'm in. We encompass the entire Missisquoi River watershed, and it was a great opportunity for me to actually spend time up there and get to know the resources that were there. And that's going to be sort of the overview of this presentation is touching on some of what I've discovered over the past 5-6 years doing work and exploring in the upper Missisquoi watershed. A broad overview of this presentation. First, I'm going to begin talking about just sort of the framework within which Vermont Fish and Wildlife manages trout populations. Then I'll touch upon some of the actual trout population sampling that we've done in the area. And then I'll start talking about some of the stream temperature monitoring that we've done as well. And then I'll wrap it up at the end. And again, hopefully have plenty of time for questions from the group. So to start, trout management in Vermont. If you ever want to know about how we manage trout in Vermont, find this document on our website online. And this is what we refer to. This is the Vermont Management Plan for brook, brown, and rainbow trout. This version was put out in January 2018, developed by Rich Kern, who is a now retired fisheries biologist with the state. Again, this goes into everything. It touches on what we do, but also provides a lot of great examples and data, the science behind why we do what we do. So it's a resource I turn to weekly, even though I'm pretty familiar with it. And it's a great resource even if people are curious and want to dive into some of that science. What I'll touch on at the start of the trout plan, though, is this sort of vision statement, if you will. And I won't read all of it, but I want to highlight a few lines of it. Basically, it's the goal of the department to manage our state's trout resources, one, to support wild trout populations, but also then to provide quality recreational opportunities. And to meet that goal, we have, as you can see, two bullets. But the one we'll talk about today is it's our policy to place priority on habitat work to really maintain and conserve those wild trout resources. Stocking is certainly a big part of our trout management in Vermont, and that's what number 2 here touches on. But what I want to emphasize and what I'm going to talk about today is, again, number 1 is how do we manage our wild trout resources through habitat protection, restoration, and enhancement. So to manage those wild trout populations, first we need to know what resources we have, what populations do we have, and that's where again our sort of just broad scale statewide monitoring comes in. This figure, and I'll say even this is a year out of date at this point. Each dot is a sampling location on a stream where the fisheries division has sampled for primarily wild trout all throughout the state. Many of those dots are multiple levels deep. Some stations have been sampled annually for the past 30, 40 plus years. And so I put this out there to show we have a large wealth of knowledge about our stream trout populations throughout Vermont. That sampling, each of those dots is almost always conducted through stream electrofishing. And that's exactly what it sounds like. We use different types of equipment to send electricity into the water that temporarily stuns trout or all other fish around. Allows us to scoop them up in nets, put them in buckets, totes, whatnot to hold on to them. We sample a certain length of a station, take multiple passes, and then that allows us to handle those fish, which they recover almost instantly after we take them out of the electrical field. We can get lengths, weights, count them, determine what species. That information gives us all of the population demographic info that we need to understand these populations. So to take this map with a bunch of orange dots and zoom into the area that we're interested in tonight, I'll pull up this. This is a stream sampling distribution map for the Trout River and Upper Missisquoi watersheds. It's a little noisy with a lot of labels and names. I still put it up in hopes that all of you on the call were pretty familiar with the area, but if you can see my mouse, like coming up through here, this is the main stem Missisquoi River, coming up through Troy into Canada, and looping back down into Richford. And right here is the Trout River watershed with all the tributaries coming off the mountains. To those yellow dots are again sampling. Yellow stars are sampling locations that we've assessed, and in most cases, several times at this point. When I first moved into the district, there were a few stars. There had been some sampling, but for various reasons, the Upper Missisquoi hadn't been the priority for the district. And when I came in, my goal was to at least sort of fill in the map and give us a baseline fundamental understanding of each of those tributaries, sort of what do we have in each of these different portions of the system. There's still a few gaps, but our coverage at this point is pretty good. So from this sampling, we can tease the data out into a couple different forms. One form is looking at the distribution of different species. And this is one way in which we can display that. So from those different sampling points and stars, this figure was generated. The blue here represents the areas that only have brook trout populations, whereas green are areas with brook trout and brown trout. And again, to orient you, here's the East Branch Missisquoi coming into Lowell, and then the main stem coming up. And in this section over here is the whole Trout River watershed. This shows that, again, we have great headwater brook trout populations in many parts of the watershed. One thing I'll say is the way this particular figure was generated is within these sort of smaller gray boxes, we call them catchments, so like small watersheds. It basically takes all sampling locations within those and says what species were detected. So in the case of like Afton Snyder Brook here, the headwaters are only brook trout, but as you come then down closer to the main stem, we start to get brown trout coming in from the main stem, which means these catchments get classified as both brook and brown trout. It's just a helpful way, especially then as we zoom out across the state, to look at species distributions in different areas. This figure came from the Eastern Brook Trout joint venture. There's a link to it right here, assessment.ebtjv.de. They're a fantastic organization. A lot of info to dig into. Basically, they put together the distribution of brown and rainbow trout in all states from Maine to Georgia, where brook trout are native. So basically, they've created this map for the entire eastern range of brook trout across the eastern seaboard. Pretty impressive if you want to start scrolling around and looking at a map. So we can look at species, but another way we can look at it is trout abundance. Again, there's a thousand different ways we could try to talk about and display abundance. What I have here in these sort of blue hashed polygons are areas where trout populations have met certain thresholds that we qualify as like very, very high quality trout populations. Specifically, these are the B1 metric for fishing use within the Vermont water quality standards. And these get designated through our state tactical basin plans. So there's certain measures that have to be met in order for a site to meet this qualification. But we use it again as a metric to demonstrate what streams have really good high quality trout populations. And what stands out is, I'll say the Trout River itself, it doesn't have too much in terms of quality wild trout populations. But once you get into the headwaters, they're great. They are some of the more impressive wild trout populations that I've seen that it's sampling in anywhere in my district. So Wade Brook in its tribs, Jay Brook, Hannah Clark, Black Falls, just really, really great wild trout population. On the other side of the mountain, Afton, Snyder Brook, and Mill Brook, they also have really great trout populations. They just haven't quite met that threshold that allows us to reclassify them. But the point here is to show like really the spine of the mountains coming down here. All those tributaries coming off of those have high quality trout populations. And there's it's pretty obvious why. They're good, intact forest blocks. There's limited disturbance. There's certainly some areas on the eastern side of the Missisquoi River down in the valley that have trout populations, but they're in more agricultural settings. They don't have quite the same elevation. The landscape is the same to support those really great populations. So that's again quick high level overview of what trout we have in their distribution. But then I want to touch on habitat as well. Really, wild trout management is habitat management. And if you want to dig into it more, it's temperature and in-stream cover. This is a paper that was actually published by Judd Kratzer. He's another biologist out of the St. Johnsbury office. And this paper basically showed that we have higher quality brook trout populations in Vermont when one, water temperatures are cold enough, and then two, when there's enough wood and streams. The wood and streams portion is what led Judd to start doing strategic wood addition. If you aren't familiar with that technique, look into it. It's incredible. What I'll talk about a little more here, though, is that first part of water temperature. Trout are a cold water species and they need cold water to survive. And they aren't going to be there if the water's not cold. And so we take that and as part of our monitoring, also monitor water temperature as well. One way we can do that is to put stationary loggers in a stream, and we put it there in the spring, take it out late fall, early winter, hopefully before the ice starts to form. And that gives us, in that logger, it'll take a water temperature reading every hour for the entire summer. That gives us very high temporal resolution at that location. So basically, over that whole time, we have really detailed information about the temperature patterns there. And here, as an example, East Branch Missisquoi, just upstream of Burgess Branch. This was in 2022. All summer long, the highest water temperature we recorded was about 70 degrees, but only 3 days were above 68. 68 is one of those magic threshold numbers for brook trout. And so to not surpass 68 more than a couple days in the entire year suggests that we should have really good trout populations there. And when we go and sample, we see that. We see there are really high quality trout populations. So it's another tool we can use to sort of inform what's going on the landscape. Another way to look at temperature data, though, instead of this high temporal resolution, so a data point in one location every single hour, is to look at it at a more of a spatial scale. One way we've done that is what we call these longitudinal temperature surveys. I'll put this figure up if you want to start looking at it while I describe it. But instead of looking at temperature in one location over time, what we try to do is get a snapshot of stream temperature across an entire reach, like in one moment in time. It's impossible for it to truly be one moment in time. This sampling was done over 2 days. But it allows us to get a relative temperature across this whole area. So this particular sampling, it was done from, again, the headwaters of the East Branch, so kind of near Fiddler's Elbow Road, all the way down to the Westfield Lowell town line. The first half of it, we walked. It was a great couple days. We got to walk the entire stream, pulling that temperature logger behind us. And that temperature logger was taking a reading every 2 seconds. At the same time, we had a GPS taking a GPS point every 2 seconds, and we could match those up. In the lower half, we paddled down, dragging that logger across the bottom. And what it shows, and you can see this color gradient, is how over the course of this the stream, the temperature warms and cools in response to various influences. Sort of the default you would think is as you go downstream, the temperature is just going to get warmer over time. That's not the case. There's a lot of diversity to the temperature regime in rivers, and especially here in the Missisquoi River. To dig into it and look at it in a slightly different way is we have this graph. So to orient you, it's same data. River mile is coming here across the x-axis, again from sort of the headwaters all the way down to the Westfield town line and in the big pull off on Route 100 there. And then each of these vertical lines are different, some of the major tributaries coming in. And in the y-axis, it's showing you the relative temperature. So this isn't saying like, okay, this is 62 degrees. It's saying relative to any other point on the graph, what is the temperature at that location? And what you can see is it changes a lot in some cases in response to tributaries coming in, but in other cases where there aren't any tributaries. And that's all associated with groundwater. So again, I look at this and I see, okay, there's some locations here right in the beginning. It starts real cold and then the temperature rises real fast for some reason. And here after Ace Brook, it spikes right at the confluence of Ace Brook and then continues to rise. And Burgess Branch, the river's much warmer after Burgess Branch comes in. But at the same time, we also see some of these locations where the temperature just drops. I'll talk about this one a little bit more in a second. Again, just before Ace Brook comes in. But then after Trulin Brook, the temperature drops a lot. But even in through these areas, you can see it's warming, and then you get a spot where it drops. It's all groundwater. If the drought this year taught us anything or reminded us of anything, it's the importance of groundwater in our cold water systems. The number of streams I sampled, that some were bone dry this fall, others looked pretty good and were filled with a lot of cold water. Again, a lot of water that was cold, and those all groundwater is not surface runoff from rain, and they had great trout populations. So groundwater is real hard to measure, but we get signatures of it in this figure. But what I want as an example is come in on this one again before Ace Brook. Before I go to the next slide to sort of point where it is like there's a warming trend going on in the stream here, and it's getting warmer. And all of this area is relatively cold and good, but it relatively speaking, it's getting warmer. And this groundwater input resets the whole river. You can see all the way until you get back to Burgess Branch, the temperature regime of that river has been reset because of this. That is important. That is significant. Um, so where it is again orient you Ace Brook coming in right here. This is the confluence of Ace Brook. You can see that warmer signature that you saw in the graph before, and the river just continues to warm from then on down. But just upstream of that, before it crosses under Route 100, this is less than 200 yards, maybe it's a couple hundred feet. The temperature dropped about 14 degrees Fahrenheit. It's just, and it was astounding. I remember, again, I'm not looking at the values as we're walking the stream, but we're coming through here and I just looked down and I saw brook trout swimming around me. And now I know why, as there's this great groundwater input. And one thing I want to sort of emphasize is like a lot of the habitat work we do is sort of the restoration side of things. How do we fix a degraded area? Like ACE comes in and warms the stream. How do we think about how do we make it so that not as warm? Restoration though takes time, money, and it may not always work great. Tree plantings will eventually work, but they take time to grow. What we need, I think, could be even more important is how do we protect what's already functioning? We were to lose this right here, again, this resets basically the entire temperature regime of the next many miles of river. It would cost a lot of money and a lot of time to try to get that back by restoring somewhere else. So as we think about conservation and protecting things, let's keep protection in mind. Identify what's good, what's functioning, and it may not be quite as attracting as like, oh, let's do a tree planting, but it can be way more important in many cases. Yeah, to wrap this all up, a few important takeaways. Again, this is from my perspective as a fisheries biologist. We work a lot with partners and partnering organizations who all have their own interests and desires. But from my perspective, they're great wild trout populations in many portions of the upper Missisquoi and Trout River watersheds. That's great. And that's something that we should celebrate and keep at the top of our minds as we work in this part of the state. We should certainly be mindful of working to restore those impacted areas and how do we improve the function ecosystem, improve the ecosystem in certain areas, but also remember to prioritize focusing on protecting those areas that are intact. Those intact and functioning areas are the reason why that first bullet exists, why we have great wild trout populations. Remember those, protect those, and we'll continue to have great trout populations in the future. And with that, here's my email address. Reach out to me at any point if you have questions. Hopefully we have time for questions now, but always happy to talk fish and habitat work or work with your organization or anyone else in the future. So with that, thank you very much.
Thanks so much, Lee. We definitely have time for questions. So I will keep an eye on the chat if folks want to put it in the chat or just come off mute and ask your question.
Yeah, so this is Jake Kucher from Westfield speaking. When you talk about healthy population, what metrics do you use? Do you mean a lot of fish? Do you mean a lot of good-sized fish? Or do you just mean healthy-looking fish?
Great question. Yeah, there's There's a lot of ways you could carve that out. So in that B1, that those blue polygons, there's a couple different metric thresholds that would allow those blue polygons to be formed. One is um, pure abundance. So like if you have the threshold is 1,000 trout per mile. And in many cases, that's when you have a lot of young of year or young juvenile fish. Uh, that's an indication that you have a healthy reproductive population that has good spawning habitat, high numbers. Another metric could be how many fish above 6 inches, which we deem as like our catchable threshold. And that's a way of saying, okay, is this a good high quality fishable population? If you have at least 200 trout per mile above 6 inches, that's a spot you want to send someone to go fishing. Or another metric could be biomass. So how many pounds per acre? In some cases, you can have really high abundance and also have really high biomass. But there are some systems where you may not have a lot of numbers, but you have a lot of big, healthy fish that just sort of dominate an area. Especially if you start talking brown trout, sometimes you just get like a big brown that holds down four in a stretch of river. There aren't going to be many other fish there, but that single fish is going to weigh a lot. And to us, that's also a high quality population. So there's a bunch of different ways you can split it up. Ask an angler and they'll ask you, like, they'll answer, do you want to catch a lot of fish or do you want to catch a big fish all day? We try to cover all of it.
Thank you. I guess another question I have, I've been fishing since I was pretty young, but I don't seem to have time as much anymore. But in areas where you have more of the browns, do the browns compete with the brookies? Do they eat them?
They can, and that's a big question. We're sort of thinking about looking into the future. Right now, we have streams that down low are primarily brown trout, up high only brook trout, and then there's an area of overlap and gradation. And we kind of want, like, we haven't seen any long lasting impacts on our brook trout populations because of that. I'm sure there's some, but if we look back, there was a study we put out comparing data from the 1950s to the 2010s. And things hadn't really changed. So it wasn't like the Browns were just racing up the upstream and out competing the brook trout. And what's driving that is like in especially higher gradient and cold systems, when water temperatures remain cold, brook trout actually have a competitive advantage to brown trout, and they can do better. Brown trout like it a little warmer. So if it's colder, the brook trout thrive and can outcompete the browns. We're wondering, how's that going to change over the next 20, 30, 40 years with climate change? That Eastern Brook Trout Joint Venture, where I serve on that committee as Vermont's representative and interact with folks from the mid-Atlantic states and North Carolina. Our experience with brown trout and rainbow trout not really outcompeting brook trout, they're not experiencing that down there. Brown trout are moving in and taking over. So we're mindful that our landscape might look like Pennsylvania's in 30, 40 years. Let's look at what they're experiencing and how do we proactively plan for that and address our management.
I guess I'm full of questions. Is there any interbreeding between different species of trouts?
No.
Okay.
So brook brown and rainbow trout are actually all different genuses. Yeah, rainbow brook trout are our only native species in trout species in Vermont. Brown trout originate from Europe, and rainbow trout originate from the West Coast. So browns and rainbows were introduced in the late 1800s and early 1900s, when fisheries management at that point was, how can we put as many different things in different places as possible, basically. Like, let's see what sticks. It's fun to read about what they tried to put in Lake Champlain. There was a lot of different things. Luckily, most of them didn't stick. But browns and rainbows, yeah, they're completely different species and genuses. So there isn't, yeah. Occasionally, you'll get, like, in a hatchery setting, you can force the issue, and occasionally in the wild, you'll see a cross between a brook trout and a brown trout. But it's like, we get a picture of one every 5-10 years from anglers, and they're sterile and don't reproduce. So,
okay, good. That's it for me.
Quick question.
Yeah.
How do you define a wild trout?
Yeah, great question. Wild trout are any fish that was spawned and born in the stream. So versus a stock trout where it was raised in the hatchery and then got put out. So as an example, we do stock the Missisquoi River in Orleans County, and like we've been stocking it with brown trout. But there are also wild brown trout there. So they originally were put there, but then they became self-sustaining. They found spots to reproduce on their own and maintain that self-sustaining population. So when I say wild, it's a fish that we didn't put in there ourselves.
I guess part two of that question, if you took a trout, what was considered a wild trout, and you open it up, what would be the color of the flesh on the inside?
It varies. It varies based on their diet. And so I know a lot of times anglers, like, they really like when it's bright orange, especially when it comes from a hatch, like a stocked fish. It was like, oh, the fish look real great this year. It's bright orange. It's all based on the feed. Sometimes our hatchery, the quality of feed that our hatchery uses is amazing. It's really good, but sometimes it changes a little bit, and then the flesh color changes. So the same thing happens in wild fish, depending on what they're eating and where they are. It can be pale or a little more on the orange side.
So it's conceivably, I'm looking back a bit, I'm writing a bit about it right now. Fishing in the 1950s, mid-1950s, when we would catch brook trout, say over in the Black River watershed, like Ware Brook, for instance, was always a favorite place. We usually, if we caught brook trout in that stream brook, they usually was a red meat interior. Would that also be related to the feed, or would there be any other kind of impact on the color of that flesh?
My understanding is it's whatever the diet of the fish is, and I could be wrong. You're pushing the boundaries of my expertise, but what I've been told is it's all diet.
Or you're bursting a bubble in the mythology I'm living with. So
I'm curious. I'm curious what the rumor was, but
thank you.
Yeah, of course.
I have a question. Is there a point along the Missisquoi where the trout are no longer wild at all?
Well, no brookies.
Or no
Where the
brookies?
brookies disappear.
Where the brookies end, yeah. So it's tough within the main stem itself. We certainly have wild brookies in the whole East Branch. Downstream of Burgess Branch, it's tough because it gets deep and it's hard for us to sample. So it pushes the limits of what we have the gear to actually do. Based on the temperatures, it probably starts to get a little more marginal through that stretch as well. I suspect there's still pockets of groundwater coming in, especially near some of the tributaries. I know there are brook trout in the lower reaches of many of those tributaries. So whether a brook trout is again down to Snyder Brook, Taft Brook, those areas, they're if they're not in there year round, I'm sure they're using it during the cooler parts of the year, and there's some movement between tributaries, and then they move into tributaries. Brook trout tend to be a little more sedentary, or they aren't always far ranging. In a headwater stream, a trout can live its life in a pretty small stretch. But that's not to say some fish, especially down low, aren't moving in between and connecting between different populations. So I'd guess somewhere in that downstream of Burgess Branch to the Westfield town line. At that point it starts to really get lower gradient, warm, deeper, siltier. Fewer brook trout certainly through there.
And how about once it comes back into Richford on this side? Do you know anything about that? I live on the Loveland Brook, so that's why I wonder, because we have, so I'm just kind of curious.
Yeah, so the main stem, when it comes back around, again, we don't have sampling data ourselves in it, but it's warmer. And so I don't suspect there's much for wild brook trout in there. I guarantee there's wild browns. I know people catch wild browns, but not in great abundances. There's a handful that people will catch. Again, the tributaries, though, some of those are very productive.
You also ask them how the fish might react like our brook.
Okay, my husband, why don't you just ask him, honey? You are.
Okay, another question. So we're on the Loveland Brook.
Yeah.
And our brook didn't dry up completely this last year, but we had parts where it was only traveling underground.
Yep.
How do the brookies react to that? Because
they will. Brook trout are very resilient. They've been here a long time. This isn't the first drought. The past couple of years haven't been the first floods. They are adapted to dealing with those, we call them stochastic events, those random events. I had a great example from our previous drought in 2020 or 2021, whatever year that was. Texas Brook, it's a tributary to the Huntington River in Huntington. I was driving around looking for dry streams, and in that year, in September, it was just bone dry. And I took a couple pictures near a bridge, just bone dry. The next year, almost to the day, we went back. There's flowing water. We sampled that same spot and caught brook trout. And like to the point where we like matched up the pictures holding the brook trout that we caught in that area of like bone dry to here are fish. Brook trout, they will find a spot to hang out. Do many die? Yes. We manage at the population level though, and the population is able to rebound provided you have connectivity. We talk about aquatic organism passage and culverts and impassable culverts. If you have some area of a river where it goes dry or they get completely and utterly blown out in high flow events, and then there's no way for new brook trout to make it back in there because you've got a 4-foot high perch culvert, you may not have many brook trout back there, which is why we talk about like improving connectivity. That improves the resiliency of those populations and their ability to recover. So I guarantee in wherever there was some pockets of water, if you had some water, to me, that means there's groundwater, and groundwater is cool. They were able to survive, and then they'll very quickly repopulate.
Thank you.
Of course.
Oh.
Now I want to pull up our sampling data from Loveland Brook too and remind myself.
Kind of a follow-up, and you mentioned that trout have a relatively small home range under normal conditions.
Some brook trout do. In headwater streams, they may not go too far. Yeah.
You talking about like a quarter mile of stream length, or
I've seen some studies where the fish may go a couple hundred yards. They certainly can and do move further, but I often hear anglers or people talk about it as like, oh, well, that's just the nursery stream. They live there for a year or two and then they move out. And we see examples of that, and we know of some examples of that. But a lot of times with brook trout, it's like, no, that's where they live, and they just don't get big. Like they may not ever get bigger than 5-6 inches in their whole life, and that's just the nature of what that stream produces. But it varies. It's not a one size fits all. But sometimes it's like, no, it's just a productive stream. They stay small and they live out their life in that area.
Great, thank you.
Lee, that temperature data that you shared fascinated me. Like, that was just super cool to see. We've had some communications and done some tree planting for the landowner on the Ace Brook section. And he indicated that there's going to be a big VTrans project between that cold sink and Ace Brook. And the fact that cold sink is so close to the road. I assume you guys get involved in those projects, but like that seems like a scary thing if this is such an important cold spot.
I did review that a couple of years ago, and the footprint is limited mostly to the approach and the bridge. But in my note to VTrans or commenting on that, I noted that temperature piece that was like, that happens right there. So just like making sure, to your point, that the footprint's limited. And what I'm curious about is like the other side of the road. Again, I haven't gone back to really dive in and try to map the nuances of what's going on there. That would be a real fun thing to do, and get a better idea of like, is that coming from the Route 100 side, or there's kind of a hillside up on the other area? There might be a little quarry up there or something. I've been intrigued. So if anyone has interest in doing some mapping over there, we can hand you off the equipment if you want to spend a few part of a day walking around the stream. So
I will check with my team, but I'm certainly interested.
Yeah, that'd be awesome. Again, I remember distinctly walking through there. And at that point, we no longer stalk through there, but we used to stalk brook trout. And it was like, look at all the brook trout. They must be all stock fish, but they were of such size variation as like, these aren't stock fish. But there were literally dozens just swimming around us. So,
that's neat.
As I'm spot burning fishing locations, but have at it.